Hi everyone, I hope you're all doing well. Today we are going to start Unit 6 of Pre-Calculus, which is about right triangle trig. Our essential question is, how do I calculate the 6 trig ratios of a given right triangle? So first of all, let's go over some details on a right triangle. So if I have a triangle here and one of the angles is 90 degrees, this is called a right triangle. Now, the side which is opposite 90 degrees is always called hypotenuse. For short, I can call that HYP or just H. Now, let's consider this angle over here. I'm going to call that theta. Theta is a Greek letter, which we use this letter to name the angles. So this is called theta. Now, the side which is opposite this angle is called the opposite side because it's just opposite of this angle. And for short, I can write up or I can also write just O. Now, the side which is next to this angle is called adjacent. I can write it as ADJ or just A. So these are the sides of a right triangle. Now let's review Pythagorean theorem. We know that if I have a right triangle, these two sides are called the legs and this one is called hypotenuse. Now, based on Pythagorean theorem, sum of square of two legs is equal to square of the hypotenuse. So let me call this side as A, this one as B, and this one C. Now, based on Pythagorean theorem, A squared plus B squared, so sum of square of these two sides is equal to the square of the hypotenuse. So this is called Pythagorean theorem. Okay, let's go to next part, definition of 6 trig functions. There are 6 functions that are the core of trigonometry. They are real functions which relate an angle of a right triangle to ratios of the side lengths. So that means if I have a right triangle here, these functions, trig functions, relate the angles to the sides, and that's all. Now let's see what functions do we have. We have 6 trig functions: sine, cosine, tangent, cosecant, secant, and cotangent. This is how we write them, and we read them, and this is how we usually write them. Sine, you can just write S-I-N. Cosine, C-O-S. Tangent, T-A-N. Cosecant, just write C-S-C. Secant, C-E-C. And cotangent, C-O-T. So this is how we write them, and this is how we read them. Now, the first 3 functions that you see are the primary functions. And the second 3 functions are functions that are derived from the first 3. So let's see, how does that work? If I have a right triangle here, and this is my right angle, and let's say this is the theta, the angle that I'm working on. If I want to find sine of theta, sine of this angle, that's basically equal to opposite side over hypotenuse. So if this is my angle, the one which is opposite that is opposite side, opposite the 90 degrees is hypotenuse, and the one beside that is the adjacent. So if I want to find sine of this angle, I take the length of opposite one and divide that by the length of the hypotenuse. For cosine, I take the adjacent side and divide that by the length of the hypotenuse. So that gives me cosine of theta. Tangent, you take the opposite side, divide by the adjacent side. So these are the rules for sine, cosine, and tangent. This is how these functions relate the angle measured to the sides. Now, what are the other 3? Cosecant is reciprocal of sine. You see, it's 1 over sine. Cosecant is reciprocal of sine. So if sine is opposite over hypotenuse, reciprocal of that is going to be hypotenuse over opposite. Secant is reciprocal of cosine. Cosine is adjacent over hypotenuse, and reciprocal of that is hypotenuse over adjacent. So I just flip whatever I have here, flip that, and that will give me secant. Cotangent is reciprocal of tangent. So it's going to be adjacent over opposite. So this is how we can calculate and find these functions. Here, I'm going to teach you a small trick to help you remember the rules for sine, cosine, and tangent, and the other three. If you always remember this phrase, so katoa, that will help you to remember the rules. How? Let me write that here. I'm going to write so, the first one, in this way. So, O and H here. What does that mean? That means sine is opposite over hypotenuse. Okay, and next one is ka. I'm going to write that like this, C, A, and H, and that means cosine is adjacent over hypotenuse. And the last one, toa, this is tangent, this is opposite, and this one is adjacent. So if you remember SOHCAHTOA, you always know that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. You can even remember the reciprocal functions, cosecant, secant, and cotangent using this. So if I know that cosecant is reciprocal of sine, so I know that I'm just going to divide hypotenuse by opposite to find cosecant. Secant is reciprocal of the cosine, so the rule for this one will be opposite over adjacent. Cotangent reciprocal of tangent, so just divide adjacent over hypotenuse. So that's how you can remember the rules for trig functions. Now let's work on this example. Over here, I have a triangle called CED, and we're trying to find the 6 trig functions for angle C and angle E. Let's start with angle C. Okay, so I'm going to take this one. Let's call that theta. Now we are interested to find all these 6 trig functions. In order to find these, I'm going to use the rules that I just learned, but before that, I need to have all the sides. Here I have this one, 6, and the other one, which is 3. I don't have the hypotenuse. How do I find the hypotenuse? Using the Pythagorean theorem. So according to Pythagorean theorem, sum of the square of 2 legs, which are these two, is equal to square of the hypotenuse. So I'm going to write 6 squared plus 3 squared is equal to, let's call this x for now. That's what we are looking for, x squared. Okay, so 6 squared is 36 plus 9, which is equal to 45. That's equal to x squared. And now what is x? That's going to be square root of 45. Notice that actually if I take the square root of x, it's going to be equal to plus and minus 40, radical 45, but I'm not going to take the negative. I'll just take the positive one because this x is the length of a side and it cannot be a negative value. So I'm not going to take the negative one, just take the positive. Now all I need to do is to simplify this radical form. I know that 45 is 9 times 5, and 9 is 3 times 3. 5 cannot be simplified more, so I'm just going to keep that. So 45 is 3 times 3 times 5. What is square root of that? Since I have a pair here, I can move them to the front of the radical as just one single 3. So this will be 3 radical 5. So now the simplified form of this radical form is 3 radical 5. So we found this side. This is 3 radical 5. Now I'm ready to find all the trig functions. Okay, let's see. Which angle am I working on? I'm working on angle C. This one, I call that theta. Now, if this is the angle, opposite of that is going to be this one. So this one is the opposite side. And hypotenuse is this one because it's opposite the 90 degrees angle. And the other one here, beside the angle, is the adjacent. Okay, what was the rule for sine based on SOHCAHTOA that we just learned? Sine is opposite over hypotenuse. What is opposite? It's 3. Hypotenuse is 3 radical 5. Now I simplify that and it's equal to 1 over radical 5. Most of the time we keep the answers as we see here, but sometimes we need to rationalize. In order to rationalize a fraction which has a radical in the denominator, we know that we don't like radicals in the denominator. So to get rid of that, we multiply both top and the bottom by radical 5. So it's going to be equal to 1 times radical 5, and the bottom will be radical 5 times radical 5, which is 5. So this is the rationalized form, but this one is most of the time is acceptable. It's good. Okay, what is cosine? We know cosine is adjacent over hypotenuse. Adjacent side is 6. Hypotenuse is 3 radical 5. And if I simplify them, it will be equal to 6 divided by 3 is 2. It's 2 over radical 5. Tangent is opposite over adjacent. Opposite is 3. And adjacent is 6. So this will be 1 over 2. Now, how do I find the reciprocals? Cosecant is reciprocal of sine, so it's hypotenuse over opposite. So it will be 3. Hypotenuse is 3 radical 5, and opposite is 3. And if I simplify, it will be just radical 5. Secant is opposite or a reciprocal of cosine. So it will be hypotenuse over adjacent. Hypotenuse is 3 radical 5 and adjacent is 6. So if I simplify, it will be radical 5 over 2. Cotangent is adjacent over over opposite. Adjacent was 6. And opposite of this angle is 3 and is equal to 2. So that's how I find all these trig functions. And notice that for the reciprocals, if I already have the primary one, sine, cosine, and tangent, I don't even used to have these rules. I don't even have to use these rules. I can just take whatever I have here as my answer and flip that. So 1 over radical 5 will be radical 5. Flip this one, it's going to be this one. Flip this one, you're going to have 2. So if you already have these 3, just flip the answer. That will be your answer. If you don't have them, then you need to use these rules to find the answer. Next, we need to find the trig functions for angle E. Okay, so this time my angle is E. So I'm going to call this one theta. Now, if this is my angle, the opposite one will be this one, and the adjacent will be this one. So based on the angle that you are working, opposite and adjacent sides might be a different thing, different side, but hypotenuse is always the same thing. Now I'm going to leave the rest for you to find sine, cosine, tangent, and all the other three for angle E. Since you already have all the sides, it will be easy to use these rules and find. Okay, now let's work on the next example. We have triangle ABC, and we are trying to find the 6 trig functions. First of all, I need to have all the sides. I have only 2, hypotenuse, because this is opposite the right angle. This is my hypotenuse. I have one of the legs, but I don't have the other one. So again, I'm going to use Pythagorean theorem. Let's call this one x for now. Now, if I use Pythagorean theorem, sum of the square of these two will be 4 squared plus x squared will be square of hypotenuse, 6 radical 2 squared. So it will be 16 plus x squared equal to 6 radical 2 squared will be 6 radical 2 times itself. 6 times 6 is 36. Radical 2 times radical 2 is 2. So it will be 72. Now I subtract 16 from both sides. And x squared will be equal to 56. And x will be square root of 56. Now I just need to simplify 56. I'm going to write that here. 56 is 4 times 14. And 4 is 2 times 2. 12 is 2 times 7. So this is 2 times 2 times 2 times 7. Now I found a pair here. I'm going to move this to the outside of the radical. So it will be 2 radical. Under the radical, I have 2 times 7. They are alone. They're not paired. So I just keep them under the radical. It will be 14. 2 times 17 is 14. So x is 2 radical 14. Now I found this side. 2 radical 14. Now I'm simply going to use all these rules and the sides to find the trig function. Let's see which angle we are working on right now. Let's start with A. So I'm going to use this one. This is going to be my start point. I call that theta. Now, the opposite of this side is this one. Opposite of this angle is this side opposite. And the next one here will be the adjacent side, and hypotenuse we said is always the same thing. Now, sine is opposite over hypotenuse. So it will be 2 radical 14 over 6 radical 2. So if I simplify, it will be radical 14 on top and 3 radical 2 here. As I said, you can rationalize this. To rationalize that, you're going to multiply both top and the bottom by the radical 2 that you have in the denominator, so you will get rid of that. But I'm going to keep that like this at this point. Cosine is adjacent over hypotenuse, so it's 4 over 6 radical 2. And as I simplify, I'm going to have 2 over 3 radical 2, because 4 divided by 2 is 2, and 6 divided by 2 is 3. Tangent is opposite over adjacent. 2 radical 14 over adjacent, which is 4. Now if I simplify that, it's going to be radical 14 over 2. So these are the first 3 functions. Now for the other ones, cosecant is reciprocal of tangent. So I can either use the formula h over o and find that from here, or if I already have sine, just flip that. It's going to be 3 radical 2 over radical 14. Okay, and secant is reciprocal of this one, so it will be 3 radical 2 over 2. Cotangent reciprocal of this one, it will be 2 over radical 14. So that's how I find the trig functions for angle A. And for angle C, again, if this is my angle, now for this one, this will be my opposite side, and this one will be my adjacent side. Oh, I'm sorry, not this one, because this is already my hypotenuse. So the adjacent is this one. So because I'm working on a different angle, now my adjacent and opposite side are going to change. Now I'm going to leave finding the 6 trig functions for C for you to work. Next example is here we already have a triangle, right triangle called SRT, and let's work on the first one. In this triangle, we have sine of angle S is equal to 1 over 5, and we are looking for side SR. Notice that in this triangle right now here, we don't have the side lengths. All we have is sine of one of the angles. How am I able to find one of the sides? So let's see. Sine of angle S is equal to 1 over 5. On the other hand, we know that sine is opposite over hypotenuse. So if I have the ratio of the sides, I can match them here. So I'm going to say the opposite of this angle is 1, hypotenuse is 5. Just match the top by top and bottom by the bottom. So if this is my angle, this one is the opposite side, and it's equal to 1. So the opposite is equal to 1. I'm just going to write 1 here. And hypotenuse is 5. What is the hypotenuse of this triangle? This one, which is opposite angle 90. And this is equal to 5. Now, am I able to find the other side? Yes. Usually, I just use the Pythagorean theorem. So, based on Pythagorean theorem, sum of the square of these two sides is equal to square of the hypotenuse. So it's 1 squared plus this side, let's call that SR. That's what I am looking for. SR squared is equal to hypotenuse squared, 5 squared. So it's 1 plus SR squared equal to 25. Then I subtract 1 from both sides, and SR squared is equal to 24. Then SR will be square root of 24. Once again, it's basically plus and minus, but we don't take the negative one. Now I just need to simplify 24. Let's see if we are able to simplify that. 24 is 4 times 6, and 4 is 2 times 2, 6 is 2 times 3. So 24 is 2 times 2 times 2 times 3. What is the square root of that? I found a pair here, so I'm going to move that outside of the radical. It will be 2 radical, and 2 and 3, the other 2 and 3 are alone here. So I'm just going to leave them inside, as 2 times 3 is 6. So it's equal to 2 radical 6. Now let's work on the other one. Tangent of t is given as 2 over 3. So let's see, what is tangent of an angle? It's opposite over adjacent. And in this case, it's equal to 2 over 3. So I match these together. Opposite side of this angle is this one, it's 2. Adjacent of this angle is this one, which is 3. And hypotenuse is what we are looking for. This is what we are looking for. Again, use Pythagorean theorem. Sum of the square of the other two sides. 2 squared plus 3 squared is equal to square of the hypotenuse. 4 plus 9, which is 13, is equal to st squared. And from here, st will be equal to square root of 13, and this cannot be simplified anymore. Let's work on the other example here. So for this one, I'm going to erase these again because we are using the same diagram. Cosecant of angle T is given. We know that cosecant is reciprocal of sine. It's 1 over sine. So it's basically hypotenuse over opposite. And it's given as radical 15 over 2. So I'm going to match them. If this is my angle, hypotenuse is radical 15. And the adjacent is 2. Oh, I'm sorry. The opposite side is 2. It's this one. Now it's asking us to find RT. Again, I'm going to use Pythagorean theorem. This is one of the legs. So I can write RT squared plus the other leg squared is equal to hypotenuse squared. RT squared plus 4 is equal to 15. That's radical 15 squared is 15. Subtract 4 from both sides. Now RT will be equal to 11. RT squared will be equal to 11, and RT will be square root of 11. And that's my answer. Okay, let's go to the last example that we have here. I'm going to use just one triangle, any triangle. Or you could also use this one, doesn't really matter because it doesn't specify the triangle that we are using here. I'm going to call one of the angles as theta. Cosine of theta is given. So if this is my angle, this one will be the opposite one. This one is the adjacent, and this one is my hypotenuse. We know that cosecant is given is equal to reciprocal of sine. That means it's hypotenuse over opposite, and it's equal to 5. How do I match the sides with this? I'm just going to put a denominator of 1 here, then match these. Now hypotenuse is 5 and opposite is 1. Now I can find the other side first. So the other side, these two are the legs. I can write a plus a 1 squared plus a squared is equal to 5 squared. So this is 1 plus a equal to 25 a squared. And subtract 1 from both sides. A will be equal to, a squared will be equal to square root of 24. I'm sorry. A squared will be equal to 24, and a will be square root of 24. And if I simplify that, it's going to be like what I did here, 2 radical 6. 2 radical 6. Okay, now I have all the sides. This one is 2 radical 6. Now what is tangent of this angle? Tangent is opposite over adjacent, and I have both of them. Opposite was 1, adjacent was 2 radical 6. And that's my answer. Okay, so this was today's lesson. Have a great day.